Okay, we're back with another indefinite integration problem here. Problem is this, it's on page 121, and it's number 18, and it looks like this. We are asked to find the integral of 2x minus 5 times 3x plus 2 over the square root of x. This problem's got it, just about got it all. All right, so it's got a radical, and we have a fraction here, and the first thing we think is, well, there must be some kind of new rule for integrals with fractions, some kind of a quotient rule for integrals, and unfortunately, there is not. So you sometimes have to be kind of clever in solving these problems and finding antiderivatives. And the principle is that if there's some algebra that you can do before we start the integration that will make the problem solvable or make it easier, then we need to go ahead and do that. And sometimes it's hard to see what the process is going to be or what the end is going to look like, so we just kind of got to go forward and do what we can do. And so we see here that we're not really sure why maybe we'd want to do this, but we have two binomials, and so we're going to start just by multiplying these together. And so we kind of FOIL them here, 2x times 3x, and we get 6x squared. 2x times 2 is plus 4x. Minus 5 times 3x is minus 15x. And minus 5 times 2 is minus 10. And in the denominator we have square root of x dx. These are like terms here. We can combine those together. And so what we end up with is still have a fraction, 6x squared minus 11x minus 10 over the square root of x dx. Now the thing about this is we're going to see problems like this from time to time. Is that we do have a fraction, but the fraction has three terms in the numerator and a single term in the denominator. So the way we're going to be able to solve this is to separate this into three separate fractions and kind of consider this square root of x to be like a common denominator, which is exactly what it is. The square root of x is the common denominator, and these are three separate fractions that we can pull apart, and it'll look like this. At the same time, I'm going to change this square root of x to be x to the 1/2 power. And so when we do that, we end up with this, 6x squared over x to the 1/2 minus 11x over x to the 1/2 minus 10 over x to the 1/2 dx. And now you can see, well, we need to do one more thing, and that is, since we have a common base of x in the numerator and the denominator, we can simplify these terms simply by subtracting the exponents. You remember that when we're dividing polynomials, if we have a common base, we can combine them together by subtracting the exponents. And so what we get here is integral of 6. Now here we have x to the second power over x to the 1/2. In other words, this is x to the 2 minus 1/2. Think about that for a second. You know that's x to the 3/2 power minus, this is x to the 1 power, x to the first power over x to the 1/2 power. 1 minus 1/2 is x to the 1/2. And here we have minus 10. And this is 1 over x to the 1/2. We can bring this up, and it becomes x to the negative 1/2 power dx. Now, having gone through those, 4 steps, now you see we arrive at an integral that we can solve. And we'll go ahead and do that. So instead of separating this into 3 separate integrals, we've done that enough times. Now we should be kind of familiar with how to do this. We can simply take the antiderivative of each term in sequence. And so this 6 is a constant multiple. So we'll pull that out, and we'll consider the antiderivative of x to the 3/2 power. Remember that we add 1 to the power. 3 over 2 plus 2 over 2 is 5 over 2, and then divide by 5 over 2. In other words, multiply by 2 over 5. And then we'll multiply these together in just a minute. Minus 11. Now we'll take the antiderivative of x to the 1/2, add 1 to the power, that's x to the 3/2 power, and again multiply by the reciprocal, and we'll combine those in a minute. And finally minus 10 times the antiderivative of x to the 1/2, negative 1/2 is negative 1/2 plus 1 is positive 1/2, and then divide by 1/2, in other words, multiply by the reciprocal. The reciprocal of 1/2 is 2, and plus a constant. Okay, so here we can combine these together. This would become 6 times 2 over 5 is 12 over 5, x to the 5/2, minus 11 times 2/3 is 22/3, x to the 3/2, and minus 10 times 2 minus 20, x to the 1/2, plus a constant. And lastly, we need to put this back in radical form. This is the correct answer, or we can write this in radical form, and it looks like this: 12 over 5 times the square root of x to the 5th power minus 22 over 3 times the square root of x to the 3rd power minus 20 times the square root of x plus a constant. And there it is.